Hello students. Today we will study some important formulae in the topic basic electricity. We will study some important formulae for you of basic electricity. Okay. So first formula is a series circuit formula. So when two or more resistors are connected in series, when two or more resistors are connected in series, then its total resistance RT is given by RT is equal to R1 plus R2 plus R3. R1 plus R2 plus R3, or the number of resistors which are connected in series. For example, 3 resistors are connected in series, then RT is equal to R1 plus R2 plus R3. Okay, so in this manner the resistors are connected. See here, so these 3 resistors are connected in series. Okay, suppose this is R1, this is R2 and this is R3. Okay, so when these 3 resistors are in series, then its total resistance becomes R1 plus R2 plus R3. Okay, for example, suppose R1 is 1 kilo ohm, R1 is 1 kilo ohm, R2 is 2 kilo ohm, and R3 is 4 kilo ohm. Then its total resistance is RT is equal to 1 kilo ohm plus 2 kilo ohm plus 4 kilo ohm, that is 7 kilo ohm. Okay, total resistance becomes 7 kilo ohms, that is 7000 ohms, 7 kilo ohms. Okay, so when resistors, two or more resistors are connected in series circuit, then total resistance RT is equal to R1 plus R2 plus R3. Okay, now the second formula, parallel circuit. When two or more than two resistors are connected in parallel, so suppose these are two resistors are there, or three resistors. Suppose these are 3 resistors are connected in this manner, and suppose this is R1, this is R2 and this is R3. Okay, so these 3 resistors are now in parallel. Okay, then its total resistance RT, 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so here 3 resistors are connected in parallel, R1, R2 and R3. Therefore, 1 upon RT is equal to 1 upon R1. These 3 resistors are connected in parallel, so 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. But if two resistors are connected in parallel, then its effective resistance or its total resistance RT is equal to R1 into R2 divided by R1 plus R2. R1 into R2 divided by R1 plus R2. Suppose R1 is 10 kilo ohm, R2 is also 10 kilo ohm, then its effective resistance or its equivalent resistance will be 5 kilo ohm, because 10k into 10k divided by 10k plus 10k. Okay, so 10k means 10 into 10 raised to 3, 10 into again 10 into 10 raised to 3 divided by 10k plus 10k, 20k, that is 20 into 10 raised to 3. 10 raised to 3 will cancel, then 5 into 10 raised to 3. 5 into 10 raised to 3 ohms means 5000 ohms, means 5 kilo ohms. 5 kilo ohms. So when two resistors, suppose 10k 10k are in parallel, then its equivalent resistance will be 5 kilo ohm. Okay, suppose 4 kilo ohm are in parallel, then its equivalent resistance will be 2 kilo ohm. If 8 kilo ohm are connected in parallel, then its equivalent resistance will be 4 kilo ohm. Okay, so in this way, when two resistors are in parallel, then its equivalent resistance or total resistance RT is equal to R1 into R2 divided by R1 plus R2. So this is the second important formula. Then third formula, voltage divider formula. Now suppose two resistors are connected in series like this. Here R1 and R2 are connected in series, and if a battery is connected across this series combination, and if we want to calculate the voltage across R2. So if we want to calculate voltage across R2, for example, suppose a 6-volt battery is connected and R1 is suppose 10 kilo ohm, R2 is also 10 kilo ohm. Now since these two resistors are of same values, these resistors are equal values, that is 10 kilo ohm, 10 kilo ohm. Therefore, voltage will divide across each resistor, or voltage will drop across each resistor equally, because this is a 6-volt battery, and because these two resistors are of equal or same values, that is 10 kilo ohm, 10 kilo ohm. Therefore, voltage across each resistor will be 3 volt. That is, voltage across R2 is 3 volt, voltage across R1 is also 3 volt. So 3 plus 3, 6 volt. Okay. So by using there is one formula, it is called as voltage divider formula. By using this formula, we can calculate voltage across R2. So voltage across R2, that is VR2, is equal to R2 divided by R1 plus R2 into applied voltage V. Okay, R2 divided by R1 plus R2 into applied voltage V. Okay. Now in this case, suppose R1 is 10 kilo ohm, R2 is 10 kilo ohm, then 10k divided by 10k plus 10k, that is 20k, 10k divided by 20k into 6. So by using this formula, we can calculate voltage across R2. This is called as voltage divider formula. Now third is a current divided formula. Now if R1 and R2 are connected in parallel, and if a battery voltage source is connected across it, and if we want to find out current through R1, that is I1. So I1 is equal to R2 divided by R1 plus R2 into total current IT. Okay, and I2 is equal to, that is current through resistor R2, I2 is equal to R1 divided by R1 plus R2 into total current IT. Okay, this is called as current divider formula. Okay, now we will study about power. So what is power? Power is defined as, it is the rate of doing work. That is, P is equal to work done upon time. It is the rate of doing electrical work. Power is defined as a rate of doing electrical work. That is work done upon time. That is W upon T. So we have already studied about voltage, current. So these are two electrical quantities we already known. Voltage, current, or resistance. These are electrical quantities. And fourth important electrical quantity is power. So we already known about 100 watt electrical bulb, or 60 watt bulb, or 25 watt soldering iron. So what is this? This is the power consumption, total power consumption of that particular device. Or 1 HP electrical motor. 1 HP means 1 horsepower, or half HP electric motor. So 1 HP means 1 horsepower, that is 1 HP is equal to 746 watt. 1 HP is equal to 746 watt. And 1 kilowatt is equal to 1000 watt. 1 HP is equal to 746 watt. Okay, so electricity bill can be calculated by using this. So 1 kilowatt hour is equal to 1 unit. and there is for 1 unit, suppose there is a 5 rupees, then total unit is calculated, and by using these units electricity bill can be calculated, electricity bill. Okay, so what is power? Power is defined as it is the rate of doing electrical work, rate of doing electrical work. So P is equal to that is work done upon time, that is W upon T, but W, that is work done, is equal to V into Q, where V is voltage and Q is charge, and I, that is current, is equal to Q upon T, that is a rate of flow of electric charge is called as current, rate of flow of electric charge. So I is equal to Q upon T, and from this equation T is equal to Q upon I, T is equal to Q upon I. So substituting this value in this equation, that is P is equal to W upon T. Here P is equal to, what is W? W is equal to V into Q divided by what is T? T is equal to Q upon I. Okay, Q upon I. I however zail, so P is equal to V into I. Q cancel away. Okay, P is equal to V into I, that is power is equal to voltage into current. This is the first equation of power. Now substituting V is equal to I into R in this equation, then second formula for power is P is equal to I square into R, because V is equal to I into R, so P is equal to I square into R. Okay, V is equal to I into R, so I square into R, P is equal to I square into R. Then substituting I is equal to V upon R, substituting I is equal to V upon R. Then third formula for power, P is equal to V square upon R. Again 1 megawatt, it is the largest unit, so 1 megawatt is equal to 10 raised to 6 watt, 10 raised to 6 watt. Okay, so we will stop here, students.